Today I want to introduce a new concept in fitting shoes. It's called evidence-based merchandising. Evidence merchandising for athletic shoes integrates the quantified structural parameter of running shoes with an individual's biomechanics, injury profile, and stature to ensure that the right shoe is selected. Today we'd like to show you how we measure for the structural parameter of shoes, and then the next video that we'll want to present to you is how we integrate it with each individual after doing a full evaluation. So to start with, number one phase in testing shoes is to place all the shoes in an incubator for 48 hours. So all the shoes are at the same temperature. This is very important. So let's show you our incubator so you can take a look at that, and we'll start with our first shoe. The shoe we're going to test for structural parameters is the new Nike 2016 Air Max. So Bernie, our statistician, is going to pull the shoe out of the incubator. And then the next step is he's going to,
This is the 2016 Air Max. We are going to weigh it. And it weighs at 12.8 ounces.
The next phase of our testing is to test the shoe for structural parameters. We'll be testing for midfoot stability, rear foot stability, cushioning, and energy rebound. So the first part of this is going to be for the midfoot stability. And what we're going to do is we're going to twist the long axis of the shoe 15 degrees. We're going to measure the resistance to that in inch pounds. The higher the inch pounds, the more midfoot stability. The less inch pounds, the less stability. So we're going to stretch the shoe first before we test it. Now we're going to do our first test, and this will be measured in inch pounds. So the shoe measures 64 inch pounds on the first test.
64?
Got that, Bernie?
Yes.
Okay. The second test is 64 inch pounds.
64.
Now, the next thing we're going to do is we're going to measure the rear foot stability. And how we do this is we measure the firmness underneath the heel. The softer the shoe is under the heel, the less rear foot stability. The firmer the shoe is, the more stability. This is measured in millimeters. What we do is we compress this heel block down vertically to 100 pounds. The further it takes to go down to reach 100 pounds, the softer the shoe is. The firmer the shoe is. Again, this will be measured in millimeters. So the more millimeters, the less rear foot stability. The more millimeters, the less rear foot stability. So let's start here. So this gauge measures how many pounds are compressing the shoe. This measures the millimeters it took to get to 100 pounds. So let's start. And that took 6.52 millimeters.
6.52.
Now we'll get one more measurement just to average those out. And we're almost at 100 pounds. and that measures at 6.18 millimeters.
6.18.
So we'll average those out to give us our actual measurement. Now, the next measurement we're going to get is the energy rebound or the bounce of the shoe. And how we do that is we compress the shoe to 100 pounds. We release this lever, and this block will ride up the rails. The further it rises up the rails, the more energy rebound. The less it rises up, the less. This will be calculated again in millimeters. So let's start this. So again, this will measure the 100 up to 100 pounds. We'll compress it. We'll release this. This will travel up, and this will give us the millimeters that it traveled. So let's start with this. Now it's at 100 pounds, and we got 10.02 millimeters.
10.02.
Okay, so let's measure it again. And this is 9.82.
9.82.
So what we have done here with this machine is we've measured the midfoot stability, the rear foot stability, the energy rebound, and the amount of cushioning that's in the shoe. All of this data is put into our software. We have a mathematical model in that software. So it'll compare every shoe to those different structural parameters. The shoes will be measured as a high stability, a moderate stability, or a minimal stability shoe. Once we accumulate all of that data, we come up with the stability index of the shoe. We do an evaluation of the customer, taking a look at their gait pattern or biomechanics, their injury profile, and their stature, and we integrate it with that the structural parameter of the proper shoe. If you want more information on this, please go to our website, www.shoetutor.com.